Have you ever wondered why we feel pain when we get hit? It's a question that has puzzled many of us, isn't it? Well, today we're going to delve into the fascinating world of our body's pain response, exploring the intricate biological process that takes place each time we encounter physical harm. This isn't just about the occasional stubbed toe or paper cut. No, we're talking about the complex, often misunderstood mechanism that kicks into gear in response to a wide range of injuries. It's a process that's been honed through millions of years of evolution, designed to protect us and keep us safe. So whether you're just curious or you're studying for a biology exam, or maybe you're a budding medical professional looking to expand your knowledge, this is one journey you won't want to miss. So buckle up and get ready. It's time to go beneath the surface. Stay tuned to unravel the mystery behind pain sensation. Pain, as unpleasant as it may be, is a crucial part of our survival. What is this sensation we call pain? It's more than just a feeling. It's a complex biological and psychological phenomenon. Pain is the body's way of telling us that something is wrong, that we're in danger or harm's way. It's a warning system, an alarm that goes off when our body is threatened, urging us to take action to protect ourselves. Now let's break down the types of pain. There are primarily two types: acute and chronic. Acute pain is a sharp, intense sensation that comes on suddenly, typically as a result of injury, surgery, or illness. It's the body's immediate response to a specific injury, and it tends to subside once the underlying cause is treated. On the other hand, chronic pain is a different beast. It lingers, persisting for weeks, months, or even years after the initial injury. It's like a faulty alarm that keeps ringing even when there's no immediate danger. Chronic pain can be linked to conditions like arthritis, fibromyalgia, migraine, and some types of cancer. It's a complex condition that can have profound effects on a person's quality of life. But why do we need pain? It may seem like a cruel trick of nature, but pain is essential for survival. Without pain, we wouldn't know if we've broken a bone, burnt our hand on a stove, or if we're suffering from a life-threatening illness. Pain grabs our attention, makes us stop what we're doing, and forces us to take care of ourselves. It's our body's way of saying, hey, something's not right here. You need to do something about it. So pain, as uncomfortable and distressing as it can be, is our body's built-in defense mechanism. It's a fundamental part of our survival toolkit. And understanding it is the first step towards managing it effectively. So, now that we know what pain is and its types, let's delve into how we actually feel it. The sensation of pain is a complex biological process that involves several steps. Let's dive right into it. Imagine you accidentally touch a hot stove. The first thing that happens is that the nerve endings in your skin, known as nociceptors, sense the extreme heat. These specialized nerve endings are like tiny alarm systems designed to detect potential harm to the body. When the nociceptors sense something harmful, like the burning heat of a stove, they spring into action and generate an electrical signal. This electrical signal, carrying the message of pain, then travels along peripheral nerves. These nerves act like the highway system of your body, carrying messages back and forth between the body and the brain. The signal moves to the spinal cord, which acts as the central hub for all these messages. Now the spinal cord has a crucial role to play in this process. It acts as a sort of relay station. It receives the pain signal from the peripheral nerves and then sends it up to the brain. But it doesn't just pass the message along. The spinal cord also processes the information, determining the severity of the pain and how the body should respond. For instance, in the case of touching a hot stove, the spinal cord might send a message back down to the muscles in your hand, telling them to contract and pull away from the heat source. Once the signal reaches the brain, it gets distributed to several different areas. The thalamus, often considered the relay station of the brain, receives the signal first. It then sends the signal to other areas of the brain, including the somatosensory cortex, which processes sensory information, the frontal cortex, which is involved in thinking and decision-making, and the limbic system, which deals with emotions. Each of these areas interprets the signal in its own way. The somatosensory cortex tells you where the pain is and how intense it is. The frontal cortex helps you make the decision to pull your hand away and not to touch the hot stove again. And the limbic system generates the unpleasant feelings associated with pain, making you feel upset or distressed. So, in a nutshell, the process of feeling pain involves a complex network of nerves, the spinal cord, and multiple areas of the brain, all working together to protect you from harm. This intricate process is what makes us feel pain when we get hit. It's a fascinating, albeit sometimes unpleasant example of how incredibly sophisticated our bodies really are. Did you know that not everyone feels pain the same way? Yes, you heard that right. Pain is a subjective experience and can vary greatly from one person to another. This is where the concepts of pain threshold and pain tolerance come into play. Pain threshold is the minimum point at which a stimulus like a pinch or a poke is perceived as painful. It's the moment when you go from feeling nothing to saying, "Ouch, that hurts." But here's the fascinating part. This threshold isn't the same for everyone. Some people might wince at the slightest pinch, while others may barely flinch even when the pressure is ramped up. Factors such as genetics and environment can significantly influence our pain thresholds. Now, let's talk about pain tolerance. Pain tolerance is the maximum amount of pain that a person can endure before they need to take action to stop the pain. It's the difference between saying, "Ouch, that hurts," and "Okay, I can't take this anymore." Unlike pain threshold, pain tolerance is more flexible and can be influenced by a variety of factors. One key factor that can influence pain tolerance is mental health. Stress, anxiety, and depression can lower our ability to tolerate pain. On the flip side, being in a positive mental state can increase our pain tolerance. It's like how a happy child might not notice the scrapes and bruises they got while playing, but an anxious adult might find a paper cut unbearable. Another factor is our environment. For instance, soldiers in battle or athletes in the middle of a game may tolerate pain that would ordinarily be unbearable. This is because their focus is elsewhere and their bodies are flooded with adrenaline, a natural painkiller. As you can see, understanding pain threshold and tolerance can provide a lot of insight into how we experience and react to pain. It tells us that pain is not just a physical sensation, but a complex interplay of our bodies and minds. And most importantly, understanding pain threshold and tolerance can help us manage pain better. So, to recap, we've journeyed through the fascinating world of pain, dissecting its essence, its types, and the intricate biological process that allows us to perceive it. We began by understanding what pain really is, a complex sensory and emotional experience that warns us about potential or actual harm to our bodies, thereby playing a critical role in our survival. We then moved on to a discussion about the types of pain, from acute pain, a sudden sensation that usually indicates a recent injury, to chronic pain, a persistent discomfort that could last for months or even years. We also ventured into the realm of neuropathic pain, a consequence of damage to the nervous system itself, and psychogenic pain, where psychological factors play a major role. Our exploration then took us to the biological process of pain sensation. We learned about nociceptors, specialized nerve endings that detect harmful stimuli and send signals to the brain. We discovered the role of chemicals like prostaglandins and neurotransmitters such as glutamate and substance P, which facilitate the transmission of pain signals. We also unveiled the mystery behind why rubbing a painful area often provides relief, thanks to the gate control theory of pain. Finally, we delved into the concept of pain threshold and tolerance. While the pain threshold refers to the point at which a stimulus starts to be perceived as painful, pain tolerance is the maximum level of pain that a person can handle. Understanding these concepts not only helps us appreciate our body's response to pain, but also aids in the management and treatment of pain. In essence, pain, while unpleasant, is a crucial part of our existence. It is our body's way of saying, "Hey, something is not right here, take care." So the next time you feel pain, remember, it's your body looking out for you. Thank you for watching. Remember, pain might be unpleasant, but it's a crucial part of our survival. Until next time, keep learning.